Long March 7, LM-7. The Long March 7, LM-7 series rocket, originally named the Long March 2F Upgraded Launch Vehicle, abbreviated as LM-2FH and nicknamed ICE Aero, is a new generation of medium-lift liquid-fueled launch vehicles developed by the China Aerospace Science and Technology Corporation, CASC. It is a sub-series of the Long March series of launch vehicles. The first rocket in this series, the LM-7 launch vehicle, completed its maiden flight on June 25, 2016. Initially designed as an upgrade and iteration of the Long March 2F vehicle, the Long March 7 and its variants were planned to serve as the basic model for China's new generation of medium-lift launch vehicles and to undertake approximately 70% of China's space launch missions in the future. Furthermore, the Long March 7 rocket series was also designed for routine missions in the Chinese space station project, with its basic model serving as the primary launch vehicle for the Tianzhou series of cargo spacecraft, playing a core role in space station resupply missions. Since 2020, in addition to the basic Long March 7 model, the series has added an improved version, the Long March 7A rocket. The biggest difference between the two is that the Long March 7A adds a hydrogen-oxygen third stage improved from the Long March 3B's third stage, giving an advantage over the former in launching high-orbit payloads. As of December 6, 2025, the series includes two types of launch vehicles, the Long March 7 basic model and the Long March 7A modified version. The Long March 7 project began in 2008 with a development team assembled by the China Academy of Launch Vehicle Technology, CLT, a traditional Chinese aerospace research and development institution. After introducing Russian RD-120 engine technology and successfully developing the YF-100 and YF-115 engines, the plan was to replace the engines of the Long March 2F rocket. The improved rocket, designated Long March 2FH, would replace the original Long March 2F's nitrogen tetroxide unsymmetrical dimethylhydrazine propellant with liquid oxygen kerosene and enhance its carrying capacity by upgrading to a high-thrust engine. However, the engine propellant change triggered a series of cascading technical adjustments, significantly increasing the project's complexity. Meanwhile, the original plan for the Long March 5 series was to include three configurations: small, medium, and large rockets. Given the significant overlap in carrying capacity between the Long March 2FH and the original medium-sized Long March 5 rocket, the decision-makers decided to merge the two projects. They combined the flight-proven high-reliability technology of the Long March 2F with a new technology system developed for the Long March 5 to create a new type of rocket, separating the small and medium-sized rocket from the large Long March 5 series, giving rise to the Long March 6 and 7 series. Although developed around the same time, the Long March 6 is actually a completely new product independently developed by a young team at the Shanghai Academy of Spaceflight Technology, CST. Except for the tank diameter and engine and propulsion technology, it has limited commonality with the Long March 5 and 7, and its carrying capacity perfectly fills the market gap between the medium-sized Long March 7 and the lightweight Long March 11. In 2010, the project was officially renamed Long March 7. According to Zhang Tao, Deputy Chief Commander of the Long March 7 launch vehicle at the China Aerospace Science and Technology Corporation, the development process required overcoming 11 major key technologies. Innovation was not only reflected in the product itself, but also throughout the development process. Project Chief Commander Wang Xiaojun stated that this was the first time China had achieved a complete end-to-end three-dimensional digital development process, forming a complete digital chain from computer-aided design, CAD, to computer-aided manufacturing, CM. At approximately 12 o'clock Coordinated Universal Time on June 25, 2016, the basic model of the Long March 7 series rockets successfully completed its maiden flight from LC-2 at the Wenchang Space Launch Site. This mission utilized the LM-7 configuration equipped with the newly unveiled Yuanzhong 1A upper stage, successfully completing a multi-orbit deployment mission. The Long March 7 series, as a medium-lift launch vehicle in the new generation of rockets, forms a systematic echelon with the heavy-lift Long March 5 series and the small to medium-lift Long March 6 series. This rocket is based on the highly reliable Long March 2F, LM-2F, which has been proven in manned spaceflight, inheriting the mature design of the 3.35-meter, 10.99-foot diameter core stage and 2.25-meter, 7.4-foot diameter liquid boosters, but with a complete replacement of the engines with new models. Compared to the expensive and dangerous nitrogen tetroxide unsymmetrical dimethylhydrazine propellant, commonly known as toxic propellant, used in the earlier Long March 2 series, the Long March 7 uses environmentally friendly liquid oxygen kerosene propellant, with its engines sharing technology with the Long March 5 and 6. This series aims to build a more economical and safer launch system, gradually replacing the current Long March 2 series and eventually replacing the Long March 3 series. So, its payload capacity to a 700 kilometers, 430 miles, SSO is up to 5,500 kilograms, 12,125 pounds. The Long March 7 rocket continues the modular design concept of the original Long March 5 series before the project separation. Its first stage is interchangeable with the booster module of the Long March 5, and although it shares the tank diameter and engine technology with the Long March 6, the development systems are completely independent. But the Long March 5 and 7 are developed by the China Academy of Launch Vehicle Technology, CLT, while the Long March 6 is undertaken by the Shanghai Academy of Spaceflight Technology, SASD. Even the avionics systems of the two rocket models are significantly different. The basic LM-7 can optimize its performance by adjusting the number of boosters or adding an upper stage to expand its mission adaptability. This modular design supports complex missions such as multi-orbit deployment and direct injection into high orbits, with dynamically adjustable payload capacity, low Earth orbit, LEO, covering 4,000 kilograms, 8,818 pounds, to 13,500 kilograms, 29,762 pounds, sun-synchronous orbit, SESO, covering 2,000 kilograms, 4,409 pounds, to 8,000 kilograms, 17,637 pounds, and geostationary transfer orbit, GTO, covering 4,000 kilograms, 8,818 pounds, to 7,000 kilograms, 15,432 pounds. The Long March 7's configuration theoretically supports configurations with 0, 2, or 4 liquid oxygen kerosene boosters. Each booster is equipped with a single YF-100 oxygen-rich stage combustion engine, providing 1,200 kilonewtons, 270,000 pounds force of thrust at sea level, or 1,340 kilonewtons, 300,000 pounds force in vacuum, with specific impulses of 2,942 meters per second, 300 seconds, at sea level and 3,286 meters per second, 335 seconds, in vacuum, respectively. Each booster is equipped with a single-axis thrust vector control system, requiring a specially designed joint control algorithm to coordinate the nozzle movements of all engines on the rocket. Its 2.25-meter, 7.4-foot diameter continues the specifications of the Long March 2 and 3 series, but because the YF-100 engine's thrust far exceeds that of the YF-20 YF-25 series, the booster length has increased to 27 meters, 89 feet, nearly double that of traditional models. On July 27, 2016, the boosters of the Long March 7's maiden flight rocket produced a fireball phenomenon upon re-entry into the atmosphere, visible in multiple locations including Utah, Nevada, Colorado, Idaho, and California in the United States. This event was widely circulated on social media, and the uncontrolled re-entry of the approximately 5-ton booster body was considered a rare case in the aerospace field. The first stage rocket uses a 3.35-meter, 10.99-foot diameter liquid oxygen kerosene propellant tank and is equipped with 2 YF-100 engines. The engines share the same power source as the boosters, but have dual-axis gimbaling capability. This first stage module is interchangeable with the booster modules of the Long March 5 series, and its diameter is designed to accommodate railway transportation limitations, allowing it to operate from all Chinese space launch sites. This contrasts sharply with the big 5-meter, 16-foot diameter core stage used in the Long March 5, which requires sea transport. Although it shares the same diameter and engines with the Long March 6 first stage, the two are independent development projects. The second stage rocket also uses a 3.35-meter, 10.99-foot diameter liquid oxygen kerosene propellant tank and is equipped with 4 YF-115 oxygen-rich stage combustion engines. 2 of these engines are fixed, and 2 have dual-axis gimbaling capabilities. It has a vacuum thrust of 706 kilonewtons, 159,000 pounds force, and a specific impulse of 3,350 meters per second, 342 seconds. Although it uses the same engine as the second stage of the Long March 6 rocket, it was independently developed by a different team. The Long March 7 rocket equipped with the Yuanzhong 1A, Expedition 1A, upper stage can effectively enhance the payload capacity for high-orbit missions and features multiple ignition capabilities. This configuration is particularly suitable for direct insertion into sun-synchronous orbits, and in fact, the maiden flight of the Long March 7 successfully achieved the deployment of multiple payloads into different orbits. By adding a high-performance liquid hydrogen-liquid oxygen rocket stage, combined with the low-latitude geographical advantage of the Wenchang Space Launch Site, the Long March 7th Geostationary Transfer Orbit (GTO) payload capacity will be increased to 4,000 kilograms, 8,818 pounds, 7,000 kilograms, 15,432 pounds. This is an increase of approximately 25% compared to the Long March 3B rocket, which was the most powerful Chinese rocket at the time, but still lower than the Long March 5's payload capacity. This improvement has been realized through the Long March 7A. This new model, which had its maiden flight in March 2020, added a liquid hydrogen-liquid oxygen third stage similar to the LM-3B on top of the basic 2-stage configuration. According to the series development plan published in 2013, a configuration using a common hydrogen-oxygen stage was also planned. The plan did not specify whether it would be used as a second or other stage, but in either case, second or third stage. Both were intended to use the YF-75 or YF-75D hydrogen-oxygen engine. The 2013 version of the same series of proposals also included a cost-effective option equipped with 2-meter, 6.56-foot diameter solid rocket boosters, aimed at providing a low-cost launch option for smaller payloads. Song Jingyu, deputy chief designer of the Long March 7 rocket, pointed out after the maiden flight that this mission successfully verified the domestically produced avionics system. The development team, in collaboration with domestic industrial departments, jointly developed a space-grade dual-core programmable logic controller, and its real-time operating system was also independently developed. The system adopts a distributed architecture design, possessing both scalability and fault tolerance capabilities. This avionics system will serve as the foundation for the development of most subsequent models, and reusability considerations were incorporated during the design phase. In a paper published in the journal Manned Spaceflight, sponsored by the China Manned Space Engineering Office, the Long March 7 rocket was systematically described as a complete launch vehicle series. Each rocket model is coded with a 2-digit number followed by a variable letter code and the prefix CZ7 in the format CZ7 ##. The first digit represents the number of core stages, 2 or 3 stages, and the second digit represents the number of boosters, 0, 2, or 4. If solid boosters are used, the suffix S is added. The paper also proposed a second stage configuration using liquid hydrogen and liquid oxygen propellant with a dual YF-75 engine, distinguished by adding HO after the code. If an upper stage is included, it is indicated by adding /SM. For example, the maiden flight model is coded CZ724/SM, representing a 2-stage liquid oxygen kerosene core stage plus 4 liquid boosters plus Yuanzhong 1A upper stage. The CZ-720 configuration is a two-stage liquid oxygen kerosene core stage with no boosters. The CZ-724S HO configuration is a liquid oxygen kerosene first stage plus liquid hydrogen liquid oxygen second stage plus 4 solid boosters. And the CZ-732 configuration is a two-stage liquid oxygen kerosene core stage plus liquid hydrogen liquid oxygen third stage plus 2 liquid boosters. The paper also published estimated payload performance parameters for some configurations. The paper also details the propellant options for each stage. Notably, the liquid oxygen kerosene second stage in the boosterless configuration uses only 2 YF-115 engines, instead of the more conventional 4. This likely means that the upper stage in this configuration is either smaller or employs a reduced load design with partially filled fuel tanks. The Long March 7 basic version is the initial configuration of this rocket series and the first model to be launched and put into service. This model consists of 4 boosters and a 2-stage rocket, primarily used to launch the Tianzhou cargo spacecraft to provide regular resupply services to the Chinese space station. When necessary, an upper stage can also be used to enhance its carrying capacity for high-orbit missions. So, the Long March 7 basic version successfully completed its maiden flight on June 25, 2016, and as of December 6, 2025, all launches of this rocket model have been successful. Since 2020, the basic version of the Long March 7 two-stage configuration has been joined by its enhanced version, the Long March 7A, LM-7A. This model retains the boosters and first 2 stages of the basic version, but adds a third stage using 2 cryogenic YF-75 liquid hydrogen liquid oxygen engines. Notably, this 3-stage technology is inherited from the Long March 3B launch vehicle. From a technical configuration perspective, the Long March 7A is quite similar to the CZ-73X series scheme initially proposed in 2013, as described earlier. The maiden flight of the Long March 7A took place on March 16, 2020 at 13:34 Coordinated Universal Time from the Wenchang Space Launch Site in Hainan. However, about 2 hours after launch, official news agencies announced the mission had failed without immediately specifying the cause of the failure. Although China was implementing strict measures to control the spread of the COVID-19 virus at the time, preparations for the rocket's maiden launch continued for several weeks before the launch. Some external observers speculated, based on unconfirmed information on platforms such as Baidu Tieba, that the reason for the failure of the maiden flight may have been a depressurization failure in one of the 4 boosters before the main engine of the first stage shut down and the rocket body was about to separate, approximately 168 seconds into flight. On March 11, 2021, the second Long March 7A carrier rocket was successfully launched from Wenchang. According to the China Aerospace Science and Technology Corporation, CASC, the satellite carried on this mission, the Test Satellite 9, is primarily used for in-orbit verification of new technologies, such as space environment monitoring.